Hey, Sophie likes math and history, and we are gonna understand how many electrons, protons, and neutrons an atom has. So, we usually do math videos, but surprisingly, chemistry has math in it. In school, math and science, or math and chemistry, would have correlations with each other, just like history and language arts. So we're gonna calculate how much an atom has, how many an atom has, with electrons, protons, and neutrons. But what are these objects am I talking about? We're going to learn about what these things are. So, an electron as a minus sign, a neutron, the letter N, and a proton with a positive sign. All these particles are called subatomic particles, and they are building blocks of our universe. These things are what we can use to make atoms. Atoms can be used to make molecules, and so on. But these different particles have different charges of themselves. For example, it's pretty obvious to say that a neutron has a neutral charge. Neutrons are stuck in the middle of an atom. They are stuck inside the nucleus. The nucleus is in the middle of the atom. And what the neutron's job is to do is it's supposed to balance the charge of a proton. A proton is also trapped in the nucleus, but instead of having a neutral charge, it has a positive charge. Protons are one of the most important subatomic particles, because not only is stuck in the nucleus, and protons and neutrons have to help each other to stay stable, but protons, the number of them determine what kind of element is. For example, in a neutral hydrogen atom, you will get 1 proton. Helium will bring you 2 protons, and so on. So the number of protons will change the type of element and the type of idea you are trying to work with. So there is one subatomic particle that is not stuck in the middle or not stuck inside the nucleus. And this one is called an electron. Electrons are the energy source for the atom, and they have a negative charge. Instead of staying stuck inside the nucleus, they orbit around the atom, and they give the atom energy. So now we understand what an electron is, a neutron is, and a proton is. Let's see how we can calculate them around here. So with this chart right here, we are now going to switch over to what's called the periodic table and see how many of those subatomic particles we can calculate. So most schools tend to start with element number 1, or we can say hydrogen. That is one of the most easiest elements to learn about, and is the most common element you would learn first in a chemistry or a biology class. So we're going to enlarge this right here so we can understand it more. Okay, so this is what it looks like. The top number up here is supposed to represent the atomic number. The atomic number means the number of protons the atom has. That makes it neutral. Well, we said earlier that protons are the ones that determine what kind of element you are trying to work with. So with here with hydrogen, we could say the atomic number is 1. And that gives us an express way to understand that a proton can bring you 1. The bottom number is supposed to represent the atomic mass. How much mass the atom has, or how much weight the atom has. They are part of something in the universe, and also they are very, very tiny. We measure them in AMU. We're going to understand what the measurement AMU means in the next video. The easiest one to calculate is the symbol. So the symbol of an element describes what it is, and it can also determine what element you're working with. The letter is basically, each element has their own set of letters that describe which one you're working with. Originally, the periodic table, the elements had their very own names in the Latin language. So that's why, instead of, here's another one for Mercury. Mercury has no association in the English language for Hg, but the letters Hg had an association of what you call Mercury in the Latin language. So it is highly recommended on your SAT to learn the Latin language, because you might get key clues for the science part. Okay, so the atomic mass, I'm going to round it to 1. The thing about protons is, if you want to find the number of electrons, it's going to be equal to the number of protons. Because if you want a neutral, happy atom, and if you want the atom to stay original like you want it to, the number of protons must be the same amount of the number of electrons. But what about neutrons? What about this one right here? Well, here's the mathematics involved with it. What we have to do is the atomic mass subtracted by the number of protons is going to bring us a neutron. However, hydrogen cannot hold a neutron. The nucleus that hydrogen has cannot hold a neutron because the nucleus is too small to even hold one. The proton itself is trapped inside the nucleus. Naturally, hydrogen is unstable because it has no neutron to stabilize the atom. Let's try another example. Let's try oxygen, because that is an essential element for what we can use. So we understand the symbol is O. The top number for oxygen is going to be the number 8. So we can understand that oxygen would have 8 protons. And we would also have 8 electrons. What is the atomic mass? So the atomic mass would be, if I ever rounded it, it would be close to 16. So let's say our atomic mass is 16. The atomic mass subtracted by the number of protons will bring us the number of neutrons. It would be 8, 8, 8. It would have this minus that would bring you the number of neutrons. But hang on. Why can't we ever understand the number of electrons? Why is that not included when we do the math for the atomic mass? The atomic mass is protons plus neutrons. But the reason why we never add an electron is because protons and neutrons are around the same weight or the same mass. Electrons are very, very tiny, however. But if you want an electron to equal a neutron or a proton, you need more than 2,000 of these to even cause any kind of effect for the atom. And naturally, no atom as of now has ever been discovered with 2,000 electrons. Maybe in the next millennium, or maybe in the next century, or blah blah blah, whatever what year it is, we could find one. But as of human civilization today, we can't find one right now. So never include the electrons for mathematics when you try to find the atomic mass. Electrons can be found if you know the same number of the number of protons. So now we got some practice of how to find and navigate through the periodic table of elements with a certain element. The number for the atomic mass, the atomic number, the atomic mass, protons, neutrons, and electrons. But we're not done yet. There's another way we can look at the periodic table. So, like this, there's another way we can see it. Let's say we're going to put lithium right here as a symbol. We're going to put the mass on the top, and we're going to put the atomic number on the bottom. So for lithium, if you look at the periodic table, we would put 7 on the top, and we would put on the bottom 3, since that's the number of protons for lithium. So if we want to find neutrons, 7 minus 3 would equal 4. So lithium would have 4 neutrons. So that is another way of saying it. You would have the mass on the top, the atomic number on the bottom, and the symbol on the right side. And it would usually be in a box. We are going to use that knowledge for the next video. And that concludes the video. So this was an easy lesson on how to find the number of electrons, protons, and neutrons. I hope this video has helped you understand the number of electrons, protons, neutrons. Thank you for watching Top Analyze Math Industry. Like and subscribe.